Alright guys, today in this video I'm going to teach you about zero and negative exponents. First thing I want us to do is to think about these problems over here on the left hand side of your screen. 3 to the third, we all know that that means 3 times 3 times 3. Alright, and if we do the math, 3 times 3 is 9 times 3, that is going to be 27. Or if you type that in your calculator, 3 raised to the third power is 27. Alright, 3 squared means that we have 2 3's. And 3 times 3 is 9. Alright, and then 3 to the first power, which is what this is, we know that that is just 3. Alright, so we have been working on how to mentally figure those out, and we also worked on how to type something like that into the calculator. So we're going to use our calculator to evaluate these last 4 problems, and we're going to see if we can figure out what happens when we use an exponent of 0, or what happens when we use an exponent that is a negative. We have learned quite a few exponent rules up till now, and now we're going to learn what these will do. So in your calculator, if you will type in 3 to the 0 power, everyone should have a calculator that tells them that that answer is 1. Alright, if you do 3 to the negative 1 power, 3 raised to the negative 1 power, and how you would type that in your calculator, 3 raised to the, and I always put the powers in parentheses, 3 raised to the negative 1 power, you're going to get a decimal, and if you will change that back to a fraction by pressing Math, Enter, Enter, to change it back to a fraction, your calculator is going to tell you that that is 1/3. Alright, same thing with the 3 to the negative 2, 3 raised to the negative 2 power. If you type that in your calculator, it's going to give you a decimal. Change it back to a fraction, and you're going to find out that that is 1/9. Alright, and then same idea for the last one, 3 to the negative 3rd power. Your calculator is going to tell you that that is 1/27. Alright, so hopefully you're starting to recognize a pattern here. 3 to the 0 power is 1, and actually if you type in any number to the 0 power, 4 to the 0 power, -7 to the 0 power, 1/4 to the 0 power, anything to the 0 power is always going to be 1. Alright, so to fill in our rule, for every non-zero number a to the 0 is equal to 1. It does not matter at all what that base is. If it is raised to the 0 power, then the answer is 1. Alright, so let's take a look at these negative exponents. 3 to the negative 1 was 1/3, 3 to the negative 2 was 1/9, 3 to the negative 3 is 1/27. Those almost mirror these up top. When we had 3 to the 3rd was 27, 3 to the 2nd was 9, 3 to the 1st power is 3. Those numbers are the same. The only difference is where they are positioned. These up here were on the top of a fraction. You don't even see the fraction because it's over 1. These down here on the bottom are made into fractions. Alright, so that is what that negative exponent does. And I don't like to think of it as move it to the bottom or fractions. I like to just think move it across the fraction bar. 3 to the 1st is normally 3, but because that's negative, we're going to move it across the fraction bar to the bottom. Again, 3 squared is 9. The negative means move it across the fraction /, and same thing here. Alright, so to fill in our rule, for every non-zero number a, an integer n, a to the negative n equals 1 over a to the n. So you see all that that negative exponent does is move that to the bottom. Alright, so in the case that that was on the bottom, let me make up another example right here. If that had said, and I'm going to use a different number, if that had said 1/2 to the negative 2, okay, so right now it's in the bottom of a fraction, that negative exponent means move it. So that means on this one I'm going to actually have to move it to the top. Alright, so that's why I don't like to say that the rule is move it to the bottom, because if it's on the bottom, it's actually going to move it to the top. So this one moved to the top is going to be 2 squared, and then we do have to square the 2, which would give us 4. Okay, so once you have moved it across the fraction bar, the negative has done its job and it goes away. So notice how when I moved it to the top, that negative exponent went away, and the answer on that example problem I made up would be 4. All right, taking a look at your next slide, I'm going to do 4 examples with you, and then I'm going to ask you to try 4 on your own. The first example says 3 to the negative 2, and we have actually already done that, but let me talk you through it again. The negative means to move it across the fraction bar. All right, once we move it across the fraction bar, the negative goes away. It has done its job. Then I do have to do 3 squared, which is 9. So the answer to that first example would be 1/9. All right, take a look at example B. Negative 7 to the 0 power. On the last slide, we talked about anything to the 0 power is 1. I have negative 7 to the 0 power. It does not matter what that base is. If it's raised to an exponent of 0, then the answer is 1. All right, taking a look at example C, and there is a fraction bar there that you can't really see, but that is 1/5 to the negative 2. Now, this is a quotient to a power. This is not just a number in here. This is actually a quotient where I'm dividing. And remember, our rule for that is everything has to get raised to that power. So I'm going to rewrite it like this. 1 has to get raised to the negative 2, and the 5 has to get raised to the negative 2. All right, well, remember the negative exponents mean to move it across the fraction bar. So this 1 to the negative 2 is going to get moved to the bottom. This 5 to the negative 2 is going to get moved to the top. So those are actually just going to trade places because both of them have a negative exponent. So on the top, I'm going to have 5 squared. On the bottom, I'm going to have 1 squared. All right, and then we're going to show off our math skills, and we're going to call this 25 as our final answer because 5 squared is 25. 1 squared is just 1. We know that we don't have to write the 1 on the bottom of that fraction. So the answer there is just 25. So that one involved a couple of our rules. We had a quotient to a power, and then we also had to deal with those negative exponents. We never want to leave negative exponents in our answer. If it has a negative exponent, then we are going to move it. All right, and look at example D. This one says 0 to the negative 5. 0 to any power is going to be 0 because think about that. If we are raising 0 to any power, 0 times itself any number of times, that is always going to be 0. All right, at this point I want you to pause the video and I want you to try the 4 examples over on the right. Once you have finished, the substitute is going to share with you what those answers were supposed to be and see how you did. So pause the video and try those. All right, let's look at a few more examples using some of our other rules. Example A here says 6 to the negative 4th times 6 to the 4th. All right, so this was the very first rule that we learned, that when we're multiplying two things that have the same base, in this case both of the bases are 6, what we do is we add the exponent. So before I start moving stuff around because of those negative exponents, I'm going to simplify using that rule first. So I'm going to add these exponents, and negative 4 plus 4 is 0. So when I multiply those together and I add the exponents, I'm going to get 6 to the 0. Anything to the 0 power is 1. So the answer for that first one is 1. All right, for example B, we have 4 to the negative 2 raised to the second power. That is a power to a power. And the rule for power to a power says that we multiply the exponents. So the base stays the same. The base is still going to be 4, but I'm going to multiply those exponents. So negative 2 times 2 is negative 4. Now, I cannot leave that as my answer because it has a negative exponent in it. I'm going to have to move that. So remember, the negative exponent says to move it across the fraction bar. All right, so the 4 to the 4th is going to be on the bottom. I can't leave the top of the fraction blank. I am going to have to put a 1. Okay, so if there's nothing up there, you do have to put a 1. Notice how when I move this to the bottom, the negative went away. Once you have moved it across the fraction bar, the negative has done its job. You don't write it anymore. All right, and then if we really want to show off our math skills, we can figure out what 4 to the 4th is by typing that in our calculator. 4 times 4 times 4 times 4. All right, and actually right at this second I do not have a calculator, so I'll let you type that in and figure out what that is, but it would still be on the bottom of the fraction. All right, example C is 1 over 3 to the negative 4. Again, the negative exponent means to move it across the fraction bar. This one, because it's in the bottom with a negative exponent, is going to move to the top of the fraction. Alright, so when I do that, I'm going to have 3 to the 4th. Notice again how the negative went away. Once you move it to the top, the negative has done its job. Alright, and then again, if you want to type in your calculator and figure out what 3 to the 4th is, 3 times 3 times 3 times 3, I believe that is 81. Don't be mad if I'm wrong, but I think that is right. Type it in your calculator and see. Alright, and then the last example down here, example D, 5 to the negative 1 divided by 5 squared. Now, there are a couple different ways you can go about this problem. You could move the term up here that has the negative exponent first and then worry with putting those together, simplifying. Or you can try to simplify first, and then if it has a negative exponent, move it. I normally tend to try to simplify first, and then if it has a negative exponent, move it. Sometimes when you start moving stuff and then simplifying, you're going to have to move it again. So this is division. We have two things with the same base that are being divided. So I subtract the exponents, and I instructed you when we first went over this rule to always do top minus bottom. So negative 1 minus 2 is going to be negative 3. Alright, so if we subtract these exponents, top minus bottom, we're going to have 5 to the negative 3rd power. Now, I cannot leave it like that. This is over 1. It has a negative exponent. I'm going to have to move it to the bottom. So now there's nothing on top. Have to put a 1 there. And then on the bottom is going to be 5 to the 3rd. Alright, and I remember from some of our other problems that 5 to the 3rd is 125. So the answer to that problem would be 1 over 125. Alright, so you try these next 4 examples, 1, 2, 3, and 4, darkening a couple of the fraction bars so you can see them. Try those, and we're going to pause the video, and then we'll take a look at the answers and see how you did. Alright, just a couple final examples that I want to show you. It says to simplify each expression, write your answer using only positive exponents. And those are going to be the directions all the time. We're never going to leave negative exponents in our answer. Alright, so this first one, 2xy to the negative 5th, all of that is being raised to the 3rd power. So this is a product with actually 3 parts. 2 times x times y to the negative 5th. Every part of that's going to have to get raised to the 3rd power. So I like to write all those in parentheses. All 3 parts of that product. The 2 gets raised to the 3rd power, the x gets raised to the 3rd power, the y to the negative 5th gets raised to the 3rd power. Alright, 2 to the 3rd power, 2 times 2 times 2 is 8. X to the 3rd power is going to be x to the 3rd. Alright, and then with this last part, I have a power to a power. Y to the negative 5th to the 3rd. If I multiply those exponents, I'm going to get y to the negative 15th. Alright, again, power to a power, we multiply the exponents. Now, I cannot leave that as my answer. I cannot leave a negative exponent. Okay, so this is going to have to get moved. This term with the negative exponent is going to have to get moved. Now, notice the 8 does not have a negative exponent. The x does not have a negative exponent. So those are going to stay on the top. They do not move unless they have a negative exponent. The only one that has the negative exponent is this y. Alright, so it is going to move to the bottom. Keeps that same power, but now it's no longer negative since I have moved it. So final answer on that one is 8x to the 3rd over y to the 15th. Alright, and last one over here, I'm going to do this quickly. 2x to the negative 2. That's the only thing that has a negative exponent on the top. Alright, so we can go ahead and move that, and I'm going to back up. There's no point in writing this step. I'm going to back up and I'm going to go ahead and move that. So the y to the 5th is going to stay on the top for a second. This 2x to the negative 2, that negative means move it to the bottom. So we're going to have 2x. Let me start over one more time. You know what, just hang on to that one. We will do that one in class together. There are several things that I want to talk to you about with that one. I can't even think of where to start without having to teach you several other things. So just hold on to this last example. Just put a star beside it. I do want you to try these 4, 1, 2, 3, 4 down here at the bottom. We're going to pause the video and let you try those, and then the sub will go over the answers with you and see how you did. After we do that, you are free to work on the worksheet, practice those problems, and then after that is the homework assignment. Good luck!